All right. How that everyone here still have some energy since it's, a bit late, or I think it's the last session. Thank you very much for coming to this talk about Kubernetes and MicroProfile. My name is Alex Soto. I work in Red Hat. I'm contributing in several magazines, and also I'm the co-author of Testing Java Microservices. If you are here in the Eclipse Con, you can use this code, this one, which basically lets you buy anything from Manning with a 40% of discount. But also, if you want, I'm also raffling 2 electronic book version of my Testing Java Microservices, and the only thing that you need to do is just follow me in Twitter with a picture mentioning me and with the hashtag EclipseCom19, and then you will get into this raffle. If there is any question, please don't wait until the end. Just raise your hand and I will try to answer it. So let's get back. I know that the talk is about Kubernetes, but let's go back a bit. Remember, Java was, or Java 1.0 was created in 1996, and Kubernetes is from 2014, so it's, a big lap of years. But also, if you are more curious about things that we are using nowadays, is J2E was created in 1999. So it's, it's pretty old technology. So let's go back and see what was happening in 1999. Let's take the time machine. And in 1999, this film was released. And I remember watching Trinity in the first scene. It was really awesome, right? Seeing this bullet time for the first time. If you have kids, well, it was released Tarzan and Toy Story 2, 1999. And the top chart for the year was, well, the number 1 was Cher, I believe. But it was really nice because if you see all the top 5 songs were done by females, which is really great. And of course, you are in Germany and you love football. All of the World Cups you have won has said that. And in 1999, United States wins the FIFA World Cup. Right? Yep. No? Maybe you. So yeah, they won the World Cup. So let's go a bit more serious. This is how we developed in 1999. We've got our monolith. We all know how a monolith looks like. It has some modules inside this monolith, several modules, and inside each of these modules there is some components as well. And then maybe 2 years ago, 3 years ago, depends, we start thinking that it would be a good idea to break down this monolith into one thing that we called microservices. So we start spreading all of these modules and components across a network. So now all our components are interconnected using the network. So we are effectively doing distributed computing. Of course, in microservices, some of the services has their own databases and multiple points of entry. For this reason, it's really important to have an API gateway, because depending on the kind of users, depending on what you're going to try to do, you're going to reach one module or another one. But of course, there are some kind of problems, is that you are deploying all these microservices independently in an isolated way, so you can choose this service to change it to a new version, and you are not changing all your application but just one small part. But what's happened when this service fails? Well, actually it's not only this service the one that it fails, it's failing all the transitive services that are calling. So the things becomes quite interesting when it's a failure. To change that, microservices added one thing that I called cross-cutting concerns for microservices, which is basically adding all these cross-cutting features that you need to implement around your service. So you've got your service implementing Quarkus, Spring Boot, Vertex, Go, or Node.js, or whatever, and then you've got to define an API, a way to discover how to invoke all the services, the elasticity, to scale up and down depending on the traffic, resilience. This is the example that I showed you before. What's happening when one of these services is failing? Pipeline authentication, authorization, logging, monitoring, and tracing. So when you are into microservice architecture, you need to deal with all this stuff. Of course, if you are into Kubernetes, you are just fixing all these problems with discovery and invocation, thanks of the concept of service, the service resource that we are putting in Kubernetes, and then we've got elasticity that you can just do kubectl scale up and you scale up and down release. Of course, if you are using OpenShift, OpenShift is that Kubernetes for the enterprises. You are using our OpenShift for the pipeline, for the logging, and for the monitoring. We are also covering these parts. And also, if you want, you can use Tekton for defining the pipeline. But of course, there are still some remaining parts, like resiliency, authentication, API, and tracing. And this is exactly what MicroProfile Spec is covering nowadays. I mean, they are covering more than this, but in terms of Kubernetes or microservices, we are covering these parts: the resilience part, the authentication, the tracing, and how to define the API. So let's see how this changes, and this happens thanks of MicroProfile Spec. MicroProfile Spec is baseline platform. It's like let's say it's a community project, like for example Jakarta E, but it's more focused on solving problems for the microservices. But again, the important thing about MicroProfile is that it's a specification. So you just have a spec, and then several vendors implement around this spec. And this is for MicroProfile 3.1, which is the latest one. It was released, I think, like 1 week ago. And you can see that it's open. There is open tracing, open API for monitoring, tracing. And then there is REST client for invoking other services, config for configuring your service, health check, GWT propagation for security, and authentication authorization, metrics, fault tolerance for the problem of, or fixing the problem of resilience that you have when you are using microservices in Kubernetes. And then it's also reusing some of the already existing specs. You can see, for example, CDI. This is the Java E CDI spec, JSON-P and JSON-B for JSONs, and then there is JAX-RS for defining endpoints. And finally, which is important here, is that there is also the umbrella, which are outside of the official MicroProfile spec, but there are important ones, like, for example, Reactive Streams operators, which allows you to create reactive code following a spec instead of a vendor locking solution. And as far as I know, there are some kind of discussions nowadays to move these Reactive Streams operators into the official specs. Of course, there are several vendors implementing MicroProfile spec. You see that, for example, this Apache Tommy is one. Then there is Kumuli, Quarkus Open Liberty, Spyara, and Elidon. These are just implementators of this MicroProfile spec. So let's see it in demo. I mean, that's just slides, and you can find all the information in the website. But let's see a bit of code. In this case, I'm going to use Quarkus. But again, you will see that I'm only using the spec. So the thing that works in Quarkus, it also works with any other solution. And the thing that does make it different, I will explain you why and how you can make it run correctly. So let me create a new project. Let me go, for example, here. Okay. Then I can do a new project. There is a Bootstrap website where you can go there and download it, and it downloads a Bootstrap project for MicroProfile. In this case, I'm going to use directly the one from Quarkus, which I'm just going to create. I'm going to use the 0.25. It's not the latest one. The latest one is 0.26, but it has been released today. And well, I have not tried it yet, so I prefer to wait a bit. Let's call it, for example, getting started. Okay, and now this just a scaffold, a project for us. I can open it. And As you can see, here I'm using one of the microprofile spec, which is JAX RS. This annotation is to set the path that you want to respond to this resource, and then I'm saying that I want to use a get, so when I'm doing a get in a /hello, I'm just getting hello. This is just a JAX RS resource. Of course, we can go here and deploy it. Try to move this a bit. Okay. And then I can open another one. Okay, then I can do a call, or well, I can do HTTP and think that it's hello. And of course, I'm getting the hello message. Then what's happening if I want to configure my application? Then I can use the microprofile config spec, which allows me to define and inject configuration values inside my Java code. And in case of Quarkus, we are using a file which is called application.properties. If you want to use a pure microprofile config spec, you need to create a file called microprofile config.properties. Since this will work as well with Quarkus, but in this case, by default, it creates an application.properties because we are using this file for other things. But it's exactly the same at the end, it's just changing the name. So you can do a greeting.message equal aloha, and then I can go here, I can change this return message for the configuration value that I've added. So the only thing that I need to do is just use config property. Notice that this is an annotation that comes from rg.eclipse.microprofile.config. So it's just the spec one. And I can put here a string message, for example. If you are using a pure microprofile spec, for example, Payara, you should put here inject as well, right? Because you need to say, I want to inject, this comes from the CDI spec, and what I want to inject is this config property that it's called greetings.message. You can work this, and it works, but in Quarkus we say, okay, I know that this is a config property, and I know that I want to inject this property inside, so I need to put this annotation. So in Quarkus, this inject is mandatory. Well, we can leave it. And then if I go here and I do again this, you see that I'm getting aloha. So this is the configuration. So this, in this case, I'm using the microprofile config spec to configure my application. More things that I can do, for example, is overwrite this value. Suppose that, since I'm in the Kubernetes system, probably you are configuring your application with a config mac that at the very end is an environment variable. So it's really easy to do. I'm just going to show you. Let me try to make this window a bit smaller. Okay. Okay, I've created my jar. Of course, if I do -jar target getting started snapshot.jar, runner.jar, I'm getting the same, and I can do here a curl, and I'm getting aloha. But if I want to override, the only thing that I need to do is just do an export, because I want to create an environment variable, which is going to do greetings or greeting message equal hi, and then of course I can again start the process, and now when I do hello, I'm getting the hi. So this is one of the great things about microprofile config. You define your configuration file, in your configuration file your values, but then you can override with system properties or with environment variables, which is the way of working with Kubernetes. Another thing that you can use is the, usually if you are into microservices and Kubernetes, is the reactive streams. Probably you want to use Reactive Approach because it helps you on saving resources. Because with reactive, what you're doing is just, when a thread is not doing anything because you're doing an I/O you're doing an I/O operation, then you can use this thread for doing other kind of operations. So you're reusing a thread instead of creating a new one. To do that, I need to add a dependency, which is the Reactive Streams dependency, which in case of Quarkus, it's called Reactive Streams operator. So I'm going to add this to my POM. I will show you what I'm doing now with extension. Now, basically what I'm doing is just adding a new dependency. Notice that Visual Studio Code shows me here that I've added a new dependency, which is the Quarkus Small Reactive Streams operator, which is the implementation of the MicroProfile Reactive Streams. And then I just need to do next thing. If I want to do reactive, I can create a new endpoint. Get. Of course, I need to change the path. Let's call it a sync. And then what I want to return, well, it produces, again, a text plain. And what this returns is not a list of things or an object, but a completion stage. Completion stage, it's here, it's a class that allows you to do things under the hood without using the main thread. So it means that when I get the request, all the logic behind is going to happen under another thread, freeing or the worker thread. So this worker thread can be reused by any other request, because usually when you are using all these, request response servers, you have a pool of threads, and when you send a request, you're taking one thread from this pool and executing all the operations on this thread. But these operations, if they are long operations like I/O, then what you want to do is free this thread to make able to get more requests from your clients. In this case, this returns, I think that it's in a string. Let's call it, for example, list. This is the name. And then I'm going to create some kind of reactive stream. To do that, I'm going to use Reactive Streams. Notice that Reactive Streams is a class for creating streams that comes from our Eclipse MicroProfile Reactive Streams. So again, I'm using the spec. And in this case, I'm going to create a new one. I'm going to put this. And I'm going to create a stream that says hello. Okay. Then what I want to do with each of these elements is put it in uppercase, and for this reason I need to use the map operation with a string uppercase. Then what else I can do is do a map. Okay, then I can run it. Let's map. Oh, it's two uppercase, I think the method. Two uppercase. Yeah. Then I can run it. To list. So I'm going to take each of these elements individually. I'm going to make it an upstream, an uppercase, and then when it's an uppercase, I'm going to put it inside a list. This is the to list. Then I want to run this, and when I finish to run, what I want to do with the result is then I can just now. Then apply, and this is the list, L2 string. So what's happening here is that I'm going to send a request to /async. It's going to execute all this iterating over hello, transform this hello to uppercase, and put it inside a list, but without blocking the main thread. So the main thread will be free, meanwhile it's doing these operations to process another incoming. And finally, when everything is finished, and you said, okay, I finished all the stuff, then a main thread needs to take the result, do a toString of the list, and send it back to the caller. This is what I'm doing here. So I can sorry. So now I can just start again, and I can go here and it's hello async, and of course I'm getting hello. The good thing is, first of all, you are not blocking the main thread. For this reason, it's important, the reactive approach. The second thing is that since you are using this, you can say fluent language or DSL, you can start applying different things. Map is for transforming the elements, but for example, I can use this thing, which is to remove the duplicated. So now if I run it again, you'll see that instead of hello, you have hello without one L, because I'm just removing the this thing. And all these things happens in another thread, not the main thread, which is important message against reactive. Of course, remember that I said that there is also OpenAPI, which allows you to visualize what's your API. This is one of the main things of the microservices. Remember, the first topic was API. You need to define an API, and probably you want to inspect what's going on in your API. To do that, you can again add a new extension, which is OpenAPI, which is from MicroProfile. I've added, and then I can deploy it again. Okay, and now I can go to localhost Swagger UI. This is the default endpoint where the Swagger is publishing the results. So OpenTracing is using the Swagger format for publishing your API. You can define it by yourself manually, or you can leverage to make automatically by the MicroProfile Spec. In this case, you can see that we have hello and we have a hello async. Of course, if I click, well, this is the Swagger API, you can just try it from here. So if I just do try and execute, I'm just getting, again, this high thing. Another important thing is health checks. If you know Kubernetes, you know that there is the concept of liveness proofs and readiness proofs, right? Liveness proof is that the pod is up and running, and the readiness proof is that the pod is ready to start receiving traffic. Usually the difference is that something is ready when you have, for example, if you need to update caches or you need to sync with a database, then your service is up and running because it has started, but you still need, you are applying some kind of under operations for updating the database schema. So this is the difference between readiness and liveness. And again, MicroProfile takes care of this. You just need to add another extension, which is health. I think that if I put health, it will be installed. Yes. And then I can create some health checks. Just need to go create a new health checks.java, new Java class. Health check relays on CDI, so I need to put this as an application scope. This is the notation of CDI. And then I can start defining a new health check. In this case, we're going to do the readiness check. I need to do that. This produce something. It produces readiness check. So you have this annotation that comes from our Eclipse MicroProfile health. Public health check. Health. See? And then I can just return health. Health check response, for example, or health, yeah. I think that it's checking if I can. We can put it here on name with it's like I am alive, for example. And then I can just say that it's down or up. Then this is where you put your logic saying, if I'm migrating some data from database A to database B, then I will put here some kind of, if the migrator has terminated, then up if it has not been terminated, that down. In this case, we can put it, for the sake of simplicity, up, and then you build this. And that's all, or not. Check. Let's check. Response. Okay. Now, we have defined this new readiness and this new readiness proof. Then to test it, you just need to start again. And if I go to HTTPI, instead of hello, I go to health / or health. Okay, let's start with health. You see here the checks saying that it's up. And if I go to health / live, is it liveness? Is it red? You're seeing that it's up because this is what I put it there, right? So we thought I can code my liveness and readiness proof in this way, in a Java way, without exposing the endpoint, and then the config automatically put it. Let me, yeah. Then, yeah, I mean, there is another thing which is metrics. If you are in the microservices, you still need metrics. So I can add the metrics spec, which comes from the microprofile again. And by just adding the dependency, I've just added this dependency, nothing else. I can go and I can just go to metrics endpoint, and you see that I'm getting all the metrics of my application, the JVM memory, the heap memory, the objects, and so on, in the format of Prometheus. So if you're using Prometheus for monitoring your application, you just add this microprofile metrics spec, and by default you get it, this /metrics endpoint, which provides good information for your Prometheus. Then I'm going to show you some example that I've already developed before. This one, which shows you other kind of microprofile aspects. One of these is the REST client. So if you have your project or your service, probably this project needs to do other requests to other services, other running services. For doing the REST calls, you can just use the JAX REST client, or you can just use the REST client spec, which basically allows you to do things like that. You can simplify this. You can just create an interface, which is called beer gateway, because I'm reaching a beer database. And then I'm just registering this as a REST client. I'm saying this interface is a REST client. And then I'm defining where is this endpoint. So I'm saying that I want to do a request using the get HTTP method in a /b2/beers. It's going to produce a JSON. I want to add a client header, which is the user agent. It will receive a query param, which is the page, because since you can get it a lot of beers, what I'm doing here is just saying I want the first page of the beer, the second page of the beer, and so on. And finally, this returns a completion stage of a list of beers. So in this case, what's happening is you're seeing here several aspects at once. The REST client, the JSON-B, because I'm binding JSON documents to Java objects. And finally, the completion stage, which is from Java JDK, but you are going to see now that I'm using the reactive approach. Then maybe most of you are saying, okay, you say that you're going to /v2/beers, but where I am defining the host, you need to define the host somewhere, right? And this is done in the configuration file. In the configuration file, you define that the class beer gateway needs to go to /mp rest, because it's microprofile rest extension /URL. The URL is api.pangapi.com. So what I'm just putting here is the URL. So you can change the URL for testing purposes without affecting all the client. And then The example is quite more, well, we can see the first page. Wait, I'm going to close this one. I'm going to start this. Okay. Here. Now we can do HTTP slash beers slash first page, which basically returns the first page of the beers. And you can see here the first page of all the beers. Then, what's happening if I want to get all the beers? It means that I need to navigate through all the pages, right? I need to grab the first page, then the second page, the third, the fourth, blah, blah, until I finish to grab all the beers. And what's happening if I want to filter all these beers, for example, for the ABB, and I want to have strong beers, one that are more than 10. Then it means that I will need to go page by page, storing all these beers in memory, iterating all these beers, filtering, and then return the results. This is one way of doing it, which is the asynchronous way, but you can change this and use a reactive approach. And the reactive approach works like this. I'm just, well, maybe you can not see the code, but I'm just using the reactive spec. I'm just generating this call. I'm calling beer.getBeers. This is the REST client, and I'm passing the page. And when I have all the results, if there is no more results, I know that I finished. And if there are more results, I want to get more and more beers. If there are more and more beers, since it's not on complete, it's going to be on next, and I'm going to return play page +1. So what I'm doing here is just a recursive calls of going page 1, I take all the beers, page 2, I take all the beers, page 3, I take all the beers, so on, until I say on complete. But remember that I said that I wanted to filter the beers for the strong beers. So now, what I do here is just say beer service. This beer service is this class that returns a flow variable, which is a reactive class. Filter that the ABB is more than or greater than 10, right? And you will say, and you are iterating, right? You are storing all the beers, and then you are iterating. But since it's reactive, it's not working this way. What is happening in the reactive code is like, I grab the first page, I filter. When I finish filter, I put it the good ones into another stream. And then I do the same for the page 2, and the same for the page 3. So in memory, I'm only allocating the ones that I really want. And then when I finish and I call onComplete, then I will call the thread, the main thread, the one that is responsible to sending response back to the client, and send only the beers that I want. So if you see here, I called beers/all, you see that all the beers are more than 10. Okay, there are several ones, and I've been iterating over all the pages without consuming as much as resources as you can use using an synchronous approach. So we are almost done. If you want to learn more about, for example, Quarkus and how Quarkus uses MicroProfile, you can go to quarkus.io or this cheat sheet. And well, let's wind down. Yeah, we are 2019. Remember the Avengers? You know, it's the I would say I think it's the most grossed film that has ever been done in the history. Guys, if you have kids, yeah, there is Aladdin and Toy Story 4, so Toy Story repeats. The music, I don't want to comment anything about the music. And US won the World Cup again. So that's all. And if you have any question, whatever, you can approach me in the conference, or you can send me a tweet, or in YouTube, or even an email. I mean, that sometimes people ask me, can I send you an email? And it's like, yes, for this reason, the mail is in the slide. If not, I will remove it from that. Thank you very much.